Let me get you started with this WeBWork problem, problem number 8 from the WeBWork question make double half angle formulas. So we're given tan theta is 8/13 and a condition on cosine theta, and then we're supposed to figure out all of these. So tan theta equals 8/13. We're going to use one of the Pythagorean identities again. Tan squared plus 1 equals secant squared. Okay, so tan squared theta plus 1 equals secant squared theta. Tangent of theta is 8/13, and 13 squared is 169. 8 squared is 64. So tan squared plus 1, so 1 in this form, so we can have a common denominator of 169, equals secant squared. 169 plus 64 is 233, so that's secant squared theta. Now, secant is the reciprocal of the cosine, so I can turn this upside down to get the cosine, but I also have to take the square root. So that gives me that the cosine of theta is the square root of 169, which was 13, over the square root of 233. Now, I was a little sloppy when I took the square root here, because I do have to remember that I'm given that cosine of theta is less than 0. So that means when I took the square root, I should have taken the negative square root. So let me write that down correctly. So cosine of theta is minus 13 over the square root of 233. Again, the reason for the minus sign, I should have picked up a plus or minus here when I took square roots, is because I'm given that cosine of theta is less than 0. Okay, let's see where we are. We know the cosine. That was right here. So we also know the secant, because it's the reciprocal of the cosine. Now, how are we going to get the sine of theta? Well, to get the sine of theta, we can take the tangent and multiply it by the cosine, right? Because tangent is the sine over the cosine. If we multiply it by the cosines cancel, leaving us with sine theta. Okay, so to get sine of theta, we take, right here's sine of theta, we take the tangent and multiply it by the cosine. Here's the tangent, here's the cosine, so we do that and we get the sine of theta. To get the sine of 2 theta, use Alex's favorite trig identity. Sine of 2 theta equals 2 sine theta cosine theta. That's the double angle formula for sine. Of course, we know sine and cosine, so we can put those together to get sine of 2 theta. Now, what about the tan of theta over 2? So we're going to use the half angle formula for tangent. We know cosine of theta, so I want to conclude this by talking through how we deal with a plus or minus issue here. Now, we know that cosine of theta is negative, so that means that theta must be in the left half plane here, somewhere between 90 and 270. But here's the key point. We also know that the tangent of theta is positive. So that means that theta can't be up in here because the tangent in this second quadrant is negative. So in fact, putting this condition together with the positivity of tangent means that we know we are in the third quadrant. So in other words, theta is not in the second quadrant, it has to be in the third quadrant. So theta is between 180 and 270, or in radians. That's, of course, theta is between pi and 3 pi over 2. Now, to figure out if this should be plus or minus, we, of course, need to understand that the quadrant for theta over 2, because that's what we're looking at here is the tangent of theta over 2. So we're going to go over here and divide by 2. So that tells us that theta over 2 is between pi over 2, divide by 2, and 3 pi over 4. So theta over 2 is in the second quadrant, greater than 90 but less than 3 pi over 4. So since theta over 2 is in the second quadrant, that's where the tangent is negative, right?